Hello, my name is Jason Laney, and I'm the Warning Coordination Meteorologist here at the National Weather Service in Santa Teresa, New Mexico. And today I'm going to be presenting to you a small version of what we call our Skywarn Basic Spotter training course. We do this constantly for our local dispatchers as our communities work to maintain their storm-ready certification. So this one doesn't go quite as long as the other, but it does include a lot of very good information. So I invite you to sit back and enjoy the presentation, and at the end I'll have my contact information. Should you have any questions or comments, of course, reach out to me and we'll be able to address those at that time. That said, let's go ahead and get right into the heart of the matter and talk about what's going on with spotter training. First of all, I mentioned the fact that I am with the National Weather Service. We're here in Santa Teresa, New Mexico. We're just one office of many throughout the area. There's actually 122 forecast offices covering the entire United States. You can see the area that we cover down at the bottom here. This is primarily going to be much of southern New Mexico and a small portion of far west Texas, but it does include the metro areas of both Las Cruces and El Paso. And we're kind of a small staff, 17 meteorologists, and we do have some technical staff on site as well. We're here 24/7. Our main purpose is to issue forecast watches and warnings in order to support our mission, which I'll be telling you about right now. That mission is the protection of life and property. We're kind of in the same business that dispatchers are in making sure that we can keep people safe. One of the best ways we do that through the National Weather Service is through timely weather watches and warnings, but those need to be communicated. And in many cases, communication is a two-way street. Our dispatchers communicate to us things that they hear from staff that are out in the field. And of course, once we have information on things, we pass it along to dispatch so that any weather hazards that may be threatening the community can be pushed out that direction as well. Now, we have lots of tools at our disposal, no doubt about it. We have radars and satellites. We launch weather balloons. We have surface observation systems throughout the area. But it really is an entire team effort. We work with Skywarn Spotters, we work with our local media, we work with our local emergency managers, our dispatch centers. It's what we call the weather enterprise, and together we can get the job done. Now, one of the reasons that we do this training, even for the dispatchers, is because we don't want things to get lost in translation. We tend to talk about words that are sometimes weather speak. So we want to make sure that we're using the same terminology because time is of an essence whenever severe weather threatens, and we want to make sure we're all on the same page. Going to talk a little bit about weather safety because you may be called on to share some of these safety tips with people on the other end of the line. In a normal spotter class, we talk about what to report. That's not going to be so important to us here today, as well as identifying severe weather features. But continuing the communication with the National Weather Service is paramount. And again, the ultimate objective in all of this is going to continue to be the protection of life and property. Now, in Doña Ana County proper, on June 26, 2012, this was the first community in our local area to become certified and recognized as storm ready. And there are lots of things that had to be done there. And of course, one of those was making sure that the dispatch personnel were trained. This has since been renewed, I believe, 4 times. It is still our premier storm-ready community, and that's why you have been asked to watch this particular presentation. So getting on to some of that terminology for you now. What is a severe thunderstorm? We'll call from time to time and tell you there's a severe thunderstorm warning has been issued for your area. Severe thunderstorms generally contain hail at least 1 inch in diameter or larger. That's about the size of a quarter. And of course, winds, damaging winds, and we classify those as winds equal to or greater than 58 miles per hour. They're not as common, but we do have tornadoes from time to time. By definition, a tornado is a violently rotating column of air attached to the base of a thunderstorm cloud and in contact with the ground. The one beneath it there, the funnel cloud, is virtually the same thing, but the difference is the funnel cloud is not in contact with the ground. Funnel clouds do many times turn into tornadoes, so they are just as important to us from a communication standpoint as tornadoes. And finally, the downburst, which can do the same damage as a tornado, but usually a much wider swath. It's a strong downdraft, a rush of cold, dense air that comes out of a thunderstorm, hits the ground, and spreads out laterally in all directions. So those are our severe classifications of storms. Now, we have all sorts of weather hazards to deal with. Obviously, we do have downburst, we do have tornadoes, we have the severe thunderstorms, but even storms that aren't severe can produce heavy rain and flash flooding. They produce dangerous lightning. They can ignite wildfire. They can contain hail, even if it's not up to severe size. And then there's the whole plethora of seasonal related weather, such as winter weather, snow and ice, and even the extreme heat. Now, while we experience all of these in our particular region, two of them really stand out as being more common and more dangerous for us locally than many of the others, even though they're all very, very dangerous. And that is the aspect of flash flooding and downbursts. If we go back for the last 20 years or so and look at the severe weather we've had in our area and try to identify which one resulted in the most fatalities, without a doubt, stand out as this is flash flooding. Now, when people hear that there's flash flooding coming, many times they're not that concerned about it, but maybe they should be. And again, this is where communication and education is going to go a very long way. Because if you look at weather fatalities over the last 10 years, 30 years, or even just last year, the number one weather-related killer outside of heat, mind you, comes from flash flooding. 20 years ago, this would have been different. It would have been lightning. And even last year, across the United States, there were 92 flash flood related fatalities, which was actually even greater than heat related fatalities. And flash floods, most definitely, as I showed you, are the number one killer, not only nationwide right now, but also in our area. Those in downbursts, they tend to do the most damage. Now, most of our flash flooding occurs during July and August, and maybe give or take a month on either side of that during our monsoon season. That has to do with, one, the fact that our soils promote runoff. The water doesn't tend to permeate and soak into our soils. It tends to run down them. And run down they do because of the varied terrain and all the arroyos and streams. So normally I would have shown a video of flash flooding, but I've got some images up here. The key to flash flooding is it doesn't have to happen just where it's raining, because the water tends to move from high ground to low ground. And the thing is, people can stay safe because cars can float in less than 2 feet of water. Even a large, heavy automobile is nothing against the buoyancy force of water. And that force, when that water is moving downstream, is quite magnified, at least in a horizontal standpoint. And it only takes about 6 inches of moving water to sweep a person off their feet. Now, we notice that most flash flood deaths occur in vehicles and at night. And the primary reason for that is the fact that, one, people feel safer crossing flooded roadways in their automobiles, but they shouldn't. And two, a lot of times at night, you can't really tell that the roadway is flooded there. So these are very important things to know. And we ask, why do people do it? Well, they've done it because they've done it successfully before. They believe if they drive fast enough, they can overcome the flash flooding. Maybe it's deceptive selling points of larger automobiles on television. But the one that stands out most of all is urgency. People say, look, I was in a hurry. I didn't have time to wait. And so we must ask this question: what is more important than your life? And that is why we tell people to always wait it out. Also, if you're going to be on foot, it's always best to avoid standing near flood waters because they rise pretty rapidly. It's always best just to be patient and wait for the water to recede. And if you happen to be in a low-lying area, especially for folks that are engaged in outdoor activities, such as camping, cooking out, things of that nature, it's always best to seek higher ground when there's rainfall in the area. It's an easy thing to remember, and this is our safety tip. Whenever you encounter any type of flooding, turn around, don't drown. We've got several of these catchphrases, and this one, of course, is one that we're hoping is going to catch on so that we can eventually reduce the number of fatalities. Now, I mentioned 20 years ago, lightning was the number one killer in the United States, and it still strikes more than 400 people here in the United States during an annual average year, and unfortunately, 50 or so of those people don't come out the other side. There's no place safe outdoors, and lightning can even strike distant from the core of the thunderstorm. It doesn't have to be raining where you are for lightning to strike. So the lightning safety tips are pretty simple. Indoors is the best place to be, and indoors you don't want to be holding on to water faucets, electrical cords, plumbing lines, because when electricity strikes your house, it can transmit through those things. And you stay away from doors and windows. And of course, the best thing to do is to stay inside and not touch anything. But sometimes we're caught outdoors and there's just no other course. Well, in that case, avoid water, high ground, open spaces, tall objects, and metal objects. And the reason being, lightning is attracted generally to the tallest object. And if you're in an open space, you are going to be that tallest object. Likewise, you don't want to get under a canopy or a tree because that's now the tallest object. And if it gets struck by lightning, the current could get transferred to you. The best place to be outdoors is to find an enclosed metal vehicle. That would be most wonderful because the vehicle is grounded. And of course, we encourage people to spread out because if lightning strikes one individual, it will have a tendency to kind of skip over to other people in the area. Again, it's real easy to stay safe during lightning storms and thunderstorms in general because all thunderstorms produce lightning. We say if you're close enough to hear the thunder, you are close enough to be struck by lightning. So when thunder roars, go indoors. Doesn't get much simpler than that. And then there's the concept of downburst. Basically, a downburst occurs with thunderstorms, and they're more common than most people think. Some are larger than others, some produce stronger winds than others. But basically what happens is we get this cold pocket of air. It can be dry or it can be moist. And it descends from the core of a thunderstorm, but when it hits the ground, it spreads out with quite a bit of force. And sometimes these winds that spread out laterally around the core of this downburst can exceed 100 miles per hour. And while that in itself can create some damage, one of the most dangerous things that this does is it tends to kick up dust here where we live because we are in a dry desert location. When the dust comes up, the visibility goes down, and when the visibility goes down, unfortunately, it can cause problems on our roadways. No one is immune to this, and of course, we have some areas that tend to deal with it more than others. This is a very infamous now event that happened along I-10 in May of 2014. And even though we knew dust storms could happen, the thing is they can happen so fast. Many times you don't even see the downburst happening until the dust immediately engulfs us and begins to reduce visibility. This is all a result of the carnage from that particular accident. And it has been repeated several times since, unfortunately, and more than likely will again. And these are many of the calls that you may have to take from time to time. So we tell people if you're driving and you see signs of dust in the distance, or there are thunderstorms nearby, be aware that they can produce a downburst and kick up the dust at any particular time. And that's why it's best to know what to do in these cases. We always recommend that you get off the road and stop if at all possible. But if you must continue driving, which by the way is not the safest thing to do, slow down as slow as possible because of the reduced visibility. Turn on your headlights, low beam, tap your brakes regularly so that others can see you. Obviously, the flashing of your brake lights will get attention to alert people that there's a problem ahead. And use the lane striping for guidance so that you manage to stay on the lanes. But if you can stop, we absolutely encourage you to do so, but never stop in the travel lanes. Pull well off the roadway, and once you get well off the roadway, turn off your lights, turn off your vehicle, take your foot off the brake. Why do we say take your foot off the brake and turn off your lights? Well, because if your lights are on, your tail lights are illuminated. If your foot's on the brake, your brake lights are illuminated. And for someone coming from behind you, when there's literally no visibility, if they see the illumination of tail lights or brake lights, they'll think that's the roadway and they're going to steer directly into you. And by the time they realize that you're not moving, it could well be too late. So again, it's best to avoid this if at all possible. But if you do encounter this situation, this is what we expect people to do. And of course, we have a catchy catchphrase for that. It's pull aside, stay alive. When you see dust forming in the distance, don't take the chances. Pull off the road, and we'll drive another day beyond that. We also have to deal with large hail around here. Remember, by definition, a severe thunderstorm is one that can produce hail 1 inch in diameter. It's more frequent than you may imagine. But even smaller hail can cause problems, such as was the case down the road in El Paso in November of 2016, when enough hail fell that it literally filled the roads, clogged the drainage, and resulted in flash flooding and these huge glaciers of hail. Now, when we talk about hail, we tend to refer to it in its size, be it a 1/4 inch in diameter, and we're talking measuring it from one side to the other, up to a quarter in size, which would be 1 inch in diameter, and then you see the numbers just get astronomical beyond that point. But a lot of times when people are talking about hail, they don't have a ruler to measure it with, so we tell them to relate it to common objects, such as pea-size hail, 1/4 of an inch, penny-size hail, 3/4 of an inch, golf ball size hail, which would be 1 3/4 of an inch, and so on and so on. So you may see or hear some of these references in some of our warnings from time to time. And then there's the talk of tornadoes. No, we're not in Tornado Alley. Tornadoes are certainly more frequent in other parts of the country because they have all the right ingredients for the tornadoes to form. But that doesn't mean that we're immune to them. We do have tornadoes around here, and most of our tornadoes are what we call land spouts. They start at the ground and they spin up. You can think of it as maybe a dust devil that gets caught up into a passing thunderstorm. And then there are the larger tornadoes, the ones that get most of the airplay, that start off as rotation in a cloud and then drop down to the ground. We refer to these as mesocyclone tornadoes, and we have had those in this area as well. They're not as common, but when they occur, they tend to be larger and more damaging. Some water spouts, though, do tend to roll on for some time. Here's a very photogenic one that showed up at White Sands Missile Range from May of 2007. This started off a swirl on the ground that got caught into the storm, just as this one out to the west of Doña Ana County on October 7th of 2015. The thing is, this happened at 10 o'clock in the morning. There was not even any rain in the area yet. It literally was a dust devil that got caught into the updraft portion of a thunderstorm. I'll talk about that in a bit. And it resulted in a landspout tornado. Now, when people are outside, this is directed towards spotters, but also to our safety personnel that may be out and about communicating with our dispatchers. Never drive into the direction of a tornado. If you're out in rural areas, and fortunately we've got a lot of those in our landscape around here, it's best to turn and go the other way. Never try to ride it out in automobiles. And for people that happen to be not on the roadways, the safest place to be is inside a building. Lowest ground, interior room on the lowest floor. Reason we say an interior room, you want to avoid windows and doors because most damage and injury to people come from flying debris. And flying debris tends to make it through windows and open doors much better than it does brick walls and stucco. So we encourage people to put as many walls between them and the outside. That's why we stay away from windows, but at all cost, avoid mobile homes. Mobile homes are no different than automobiles, and automobiles provide absolutely zero protection in the case of tornadoes. Now, so that's a little bit about the weather hazards that we have in the area and some general safety tools. Obviously, when we give true spotter training courses to people that want to spot, we do talk about a lot more than this. And if you are interested in attending one of those and becoming a Skywarn spotter, we'd love to have you. In the meantime, let me just take you through some thunderstorm basics. And this is a classic type of thunderstorm. We have all sorts of thunderstorms, but the ones that produce most of the severe weather are what we call supercells. They're thunderstorms that have updrafts and downdrafts that are separated. You may not know what I'm talking about, but basically an updraft is rising air that feeds moisture and energy to the storm. Downdraft is where the wind and rain and hail are all coming from, and that's the end result that we experience down here on ground level. Now, a lot of thunderstorms that classify as supercells, they don't have a lot of rain but can still produce large hail. We call these low precipitation, obviously, because they're not producing much precipitation. Those are pretty common around here because of our drier, low levels that we have living in the deserts. And then there's the occasion where the moisture is plentiful and these things produce so much rain that you can't really see what's going on inside them. These can be very, very dangerous. But we're going to look at the classic. We're going to split the difference between the one that doesn't produce much rain, the one that produces way too much rain, and look at the classic one that's kind of halfway in between. And when you look at these things, there are things that we can notice depending on how far we are from the storm. For instance, if you're 30 to 100 miles from the storm, you're not going to see what's happening at the ground, mainly because of the curvature of the earth and too much stuff in your way. Let's face it, our line of sight's not that great, but you can see the top of the storm. And whenever we see the top of a storm, it begins to spread out, and that spreading out is what we refer to as the anvil. But whenever we see a buildup of clouds going up above the anvil, that tells us there's a major updraft taking up. And what gives us a clue as to how strong a storm is how strong its updraft is. We call this an overshooting top, and anytime you have an overshooting top, you're going to have more than likely severe consequences from weather down on the ground. The other thing is what's causing the top of the cloud to spread out in that anvil are strong winds aloft. But if that updraft is so strong that it can literally push the anvil back into the headwind of that upper wind aloft, then that too is a sign of a very strong updraft. By the way, we refer to that as a back sheared anvil. So we've got a couple of pictures here, and one of these is an anvil that is much stronger than the other, and I don't see the overshooting tops, and there may be a little back shearing going on, but there's another visual clue here. Look at the anvil on the right. Notice how wispy and thin it is. There's not a lot of moisture that's been tossed to the top of the storm. But if you look at the one to the left, look how chunky and thick that anvil is. That represents a lot of energy and moisture. Moisture is the energy in this case, by the way. It contains what's called latent heat that's released into the storm. And that thing is so chunky because the updraft is so strong, it has sent so much of it its way. Now, say you're 10 or 30 miles away from a storm. Well, you can't see the top of the storm as well, and you're still too far away to see the bottom, but the midsections can also give some clues. Remember that chunkiness I talked about? Moisture or energy to feed the storm being drawn up into the storm itself on the updraft or the rising air currents? Well, when you see a chunky mid-level column, maybe cauliflower type structure, that too is a sign of very, very strong updraft. Another clue that you can see that's not updraft related, it has to do with additional updrafts or more energy eventually available to the storm, and those are little bitty towers building on the back side of it. We call that a flanking line. But going back to that main tower, if you ever see things that look like striations, you know that that thing is beginning to rotate. And not only do we look for a thunderstorm that has a strong updraft, but an updraft that can rotate, that can cause the storm to sustain itself for a long period of time, and that itself can cause a severe thunderstorm. So two updrafts here, number one, number two. My question is, do you know which one is strongest? Well, they're both a little on the chunky side. That's pretty good. Obviously, number one's chunkier than number two. But if you look close, it's not solid striations, but do you notice these little kind of barber pole kind of breaks that you have inside that cloud? That one also appears to have some rotation. So definitely main tower number two is the big one. But really, if you're close enough to a storm to see the base of the storm, that's when you're going to get your best clues as to whether this storm can and potentially will become severe. Because you can see the updraft and the downdraft. You may not know it's an updraft, but do you notice where the cloud is dark but it's not raining? The reason it's not raining is because the air is rising. That's an updraft. And then where it gets dark underneath the clouds, you can see the rain shield over there, the blue arrows. Well, that's the downdraft. And one of the areas that is of most importance is where the updraft and the downdraft come together. I call this the action area of the storm because something very dangerous could happen in this area. It's called a lowering of that rain-free base. It's the wall cloud, and a wall cloud can many times become the precursor to a tornado. And you can see here we've got one wall cloud. It's just kind of rotating and spinning away there. You can see on the right here the striations of the main storm updraft. Remember I talked about a tornado that starts in the cloud and comes to the ground, the bigger ones? I call them mesocyclone tornadoes. Well, this is a mesocyclone with a wall cloud beneath it. So wall clouds are definitely something to watch for. Here's another image of a wall cloud that was not taken in the Doña Ana area. It was down south of El Paso. Actually, at this time, the storm was across the international border in Mexico, and this wall cloud did eventually lead us to issue a tornado warning on it. So again, what is a tornado? I gave you this definition earlier. I'll give you one more time. It is a violently rotating column of air that stretches from the base of a thunderstorm and is in contact with the ground. Now, the thing is, you don't always see it, because that air could be dry air spinning around in a circle. What you see in the classic tornadoes are what's known as a condensation funnel. But if you look at the ground, you can look for telltale signs of dirt and debris being tossed around on the ground. That would tell you that it is still a tornado. I mentioned the fact that we have two types of tornadoes around here that fit this category. One is the mesotornado. They're not as common, but they do happen. That is a tornado that starts at the cloud, goes down to the ground. It becomes a mesocyclone, the rotating of the storm tower itself, the former of the wall cloud, then the funnel cloud, which, by the way, a funnel cloud is just like a tornado. It's just not touching the ground yet, and then eventually comes down and touches the ground. The more common type of tornado, and these are very difficult for us to warn for, many times our warnings are after someone has spotted it. This is like a glorified dust devil that gets sucked into the storm. These are tornadoes that ascend. They rise from the ground and go into the updraft portion of the storm. Then there's something that looks a lot like a land spout, but it's not a tornado at all because it never touches the cloud. It's a gustnado. These tend to form along outflow, which is cold air rushing away from the thunderstorm. Even if it's not a downburst, there's still going to be wind associated with this thunderstorm, and it can create a little spin up on the edges. They look the same, but they're not quite. These are land spouts, especially the one in Las Cruces from 2001. Notice how it's down on the ground. It's a very dimly lit and hard to see rotation, but it does touch the cloud. It's much easier to see this one in Animus from 2005 that's reaching up and touching the clouds. But then we have another from Las Cruces in 2006, and it looks just like the other one, but perspective is everything. These were nothing more than big old dust devils on the outflow of a thunderstorm. They did not spin up and touch the clouds. So gustnados, not quite tornadoes yet, but nonetheless, they can still do some damage. Look at this gustnado that happened in Alamogordo in 2006. This thing was a monster, and it did some damage to some outbuildings because winds still got up to about 65, 70 miles per hour with this monster gustnado there. And of course, you can see the dust. And we've talked about the danger that dust can bring. Now, whenever we have tornadoes, we classify them based on intensity. We never know how strong a tornado is while it's occurring. It is after the fact when we go back and we do a storm survey. And this idea was brought about in 1971 by Ted Fujita, and his estimate was based on damage. It was called the Fujita scale. And then several years ago, it was overhauled because we realized that you can have considerable damage done from lesser winds if the structure is not that sound to begin with. So this is called an enhanced Fujita scale, and we go out and produce these types of surveys after every tornado that is reported. So they go on the scale from EF0 to EF5. Basically, zeros and ones are weak tornadoes, 2 and 3 are strong tornadoes, and 4 and 5 are violent tornadoes. But don't be confused by the classification of weak. All tornadoes can potentially be dangerous and deadly. Weak tornadoes, the EF0s and 1s, generally make up about 88% of all tornadoes. So the good news is most tornadoes do fall in the weak category. And because of that, they don't account for a large portion of tornado-related fatalities, about 5% there. They're usually touching down briefly and not on the ground for that long, but they can still have winds up to 110 miles per hour. Strong tornadoes, the EF2s and the EF3s, well, those are more significant. About 11% of tornadoes fall in this category, and up to 30% of tornado-related deaths. These can have passed as long as 10 to 15 miles, which means they can be on the ground for a while. And you see the wind speeds, 1 in 11 to 165 miles per hour. And then there are the biggest of the big, the violent tornadoes, the EF4s, the EF5s. They only account for 1 out of 100 tornadoes. But unfortunately, 70% of all tornado-related fatalities annually tend to come from these violent tornadoes. These can be on the ground for literally hours with path lengths exceeding 70 miles. And they can be as wide as a mile with winds topping 300 miles per hour. These have not been reported in our area as of recent, and hopefully they won't. But again, these are things we must watch. What we do tend to get most of our wind-related damage from, believe it or not, are not tornadoes, but downburst. I talked about the downburst being this rush of air that comes out of the base of a thunderstorm and begins to spread out in all directions. Well, you may have heard the phrase macroburst, microburst. Well, they're all the same. Macrobursts are just covering a larger area of damage and wind than a microburst, but they're all downburst. And sometimes they can be wet, which means they're visual. They can be dry, which means we don't see them until they kick up the dirt, or maybe a little combination of those. Again, just like the landspout tornadoes, which are much more common in this area, they're hard for us to detect and warn for. We really need ground truth verification of folks that can actually see these things, but kind of take you through it. Think of this as being a big water balloon, okay? You've got this cold, wet pocket of air. It's coming out of the cloud. It hits the ground, and when it hits the ground, it literally spreads out with quite a bit of force. And sometimes on its outer edge, it'll even spin back up. Do you see how this looks like maybe a couple of Dutch clogs or wooden slippers here? One pointed to the left, one pointed to the right, where they kind of the toes bend up. I've even had folks tell me this looks like a pair of clown shoes there. Well, where do you put your shoes? You put them on your foot, right? We tend to refer to this structure as a rain foot, or if it happens with dust, as a dust foot. Here is a visualization of it taken with high-speed photography, and this is a wet microburst. Again, we can see these, but this happens so rapidly that between one scan of our radar and another, we may completely miss these things, so we really need folks to report this in. Our law enforcement officials that are out on patrol can report these to dispatch. Dispatch can get these to us at the National Weather Service. Sometimes we know about them because take a look at this one. This is a wet microburst that hit the ground. It spread out in every potential direction. And it turned out the National Weather Service knew all about it because you can see the rain foot. Notice there's a rain foot here. See how it spreads out in all directions in circular? This happened directly over the National Weather Service where I am located recording this in Santa Teresa, New Mexico. The winds from this exceeded 70 miles per hour for an area of about 14 miles. Well, not 70 miles per hour. We saw some limited damage 14 miles from this, but the 70 mile per hour winds went out a good 2 to 3 miles from the core of this downburst. But they had winds upwards of 40 miles per hour up to 14 miles away. So microbursts are serious. And again, a lot of times microbursts are related to some of the thunderstorms that we refer to as severe thunderstorms. So that in a nutshell is about a half-hour look at our modified spotter training for you guys, the dispatchers. I did not want to have to make your training last any longer than at all possible. But I do know that a lot of you are interested in weather, and you're going to be coming up with some weather-related questions from time to time. Whether it's related to this particular training or any time that you have questions, remember we're all on the same team. We're working together for the protection of life and property. So my name is Jason Laney. I'm the Warning Coordination Meteorologist here at the National Weather Service in Santa Teresa, New Mexico. I serve your area. There's my telephone number, 575-589-4088. You can call at any time. I'll get the message. Or a better way to reach me is via email. It's jason.laney, just my name, jason.laney@noaa.gov. I hope you guys have enjoyed this. I hope you found some of this stuff to be interesting and informative, and maybe even sparking a little more interest. And if you would ever like to participate in a full-blown spotter training course, we do those virtually for a while now, and I would love to do those for you. All it takes is a simple request. So I hope you guys continue to do a fantastic job. We love working with you as our partners, and may you continue to stay safe in the days ahead. Bye-bye.